Welcome to the Cancer Answer Masterclass. Let's get started in 2 seconds. All right. A little bit of a disclaimer here that the information that I present here is not intended to treat, cure, or diagnose any specific disease. It is just meant for informational purposes only. If you plan to partake in any type of program, you need to seek out a healthcare professional. All right. With that said, let's jump right in. So, the question I ask myself when we look at cancer, and everybody's familiar with this, right? It's one of those things that people fear a lot. Now, from a practitioner standpoint, my question is, are we really winning the war against cancer? In 1971, President Nixon declared the war on cancer, and he created the National Cancer Act of 1971. He asked for an extra 100 million to launch a campaign because they wanted to find a cure for cancer. Now, when we look at the statistics over the years, now, don't get me wrong, we've come a long way with cancer research. We know a lot about cancer, how it how it develops, and some of the things that can actually stop the growth. We know all those things. But when we look at winning the war against cancer, I think some of the things that they measure it by, when they look at mortality rates, are we increasing lifespan? And we're doing a good job at it. Well, I shouldn't say excellent job. We're doing an okay job, meaning that say the life expectancy from period of diagnosis for a certain cancer was 18 months, we maybe extended life to 2 to 3 years. Okay, that's actually an improvement, right? But when we look at the term winning the war against cancer, I look at it from a standpoint of, have we done anything to decrease incidence? Incidence is the occurrence. Okay, how much rates of cancer are we seeing? And that should actually be going down if we're winning the war. But if you look at this from 1971, the declaring of the war on cancer here, we've seen an increase in incidence. Okay. So, in my opinion, we have not been winning the war on cancer. Well, let's take a look at it. There's always a money trail. All right. The world in 2015, we've spent over $107 billion worldwide on just cancer drugs. That's predicted to rise to about 150, $170 billion by 2020. That's next year. Now, the average cancer patient is going to spend about 100K, $100,000 per year on cancer drugs. Okay. Now, when we look at this bottom one here, guys. This bottom one is really alarming, and I saw this on PR Newswire, and it listed lung cancer as a segment is expected to grow, stomach cancer as a segment is expected to grow, and when I look at this, it looks like an investment chart here, right? It looks like we are taking some type of stock, and we see how it's going to grow over time. That's kind of scary when you look at it from that standpoint. And the real the real issue behind it all is, you know what? Cancer's a business, guys. There are big profits to be made. There was another article that was written, and this one really caught my attention. And it says, according to this data, the average cost of developing a cancer drug is about $720 million. So the research and development is about $720 million, but the average annual revenue for it is about 2.7 billion. That's a huge profit margin. So, from a strict business standpoint, if you have that type of a margin, would you want to find a cure? I'll leave that up to you to answer. So, the question ultimately is what, who, thing, whatever, what's to blame? We always want to look for the culprit. Now, for years, the research has been showing that it's DNA mutations. Now, is it just about the DNA, right? Now, if it was about the DNA, we have done extensive amounts of research and we have extensive amounts of therapeutic interventions towards that. Shouldn't we see a drastic improvement, right? With cancer survival rates. We should be seeing that. Now, when we look at DNA as being the cornerstone, is it just about the DNA damage? Well, in science, they looked at it and said, well, if it's just about the DNA, and if the DNA is damaged and that's what's causing a cancer cell to develop, then if we take the DNA from a cancer cell's nucleus and we put it into a normal cancer cell, what should happen? Shouldn't the normal cell turn cancerous, right? So that's what they did. They took the DNA from a cancer cell and they switched it out into a normal cell, and they found a couple of things. Okay, they found that it did not turn into a cancerous cell. That was a surprising thing. But now what they did was they took the normal cell, they took its nucleus, and they implanted that into a cancerous cell, right? So if it's just about the DNA, if you take a normal cell, its nucleus, and you put it into the cancerous cell, it should turn back to a normal cell. But that did not happen. So when we look at a few of the common culprits there, we see these different things. And we're going to get a little bit more into this down the line, what we call your epigenetic factors, right? There are things above the genome, the lifestyle traits. Okay, we see a decrease in oxygen, chemical toxins, ionizing radiation, nutrient depletion, chronic infections, and we see structural imbalances. Those are some of the few of the culprits. Okay, so now let's take a look at a normal cell. A normal cell will gather in, it'll take in the food that you're eating. The food ultimately goes to that little red guy there called the mitochondria. Mitochondria then utilizes that, makes some ATP, utilizing different, nutrients and oxygen. And then it also makes metabolic waste products into the extracellular matrix. Now, with a cancerous cell, and what happens is, you get the food going in there, goes to the mitochondria. Unfortunately, what happens there is that they found that the mitochondria is not working properly, usually due to some type of toxic assault. And then the mitochondrial DNA sends a signal to the cellular nuclear genome, and it says, "Hey, we're under attack. Trigger survival genes." And ultimately, that's what a cancer cell is. It's a survival mechanism when the cell thinks that it's under attack. And primitively, what we've seen with cells is when it encounters environments, specifically environments that is either overly toxic or lack of oxygen, these things will be triggered. Okay. So here's what happens there is the oncogenes are activated. Now the cells go into alert mode and they turn cancerous. Now, a cell, its whole goal is to make energy to survive because you need ATP. And in the presence of toxins and the lack of oxygen, it needs to turn to another form of energy production called fermentation. And it's this fermentative process that it will switch into. And that's ultimately what a cancerous cell does. And through the process of fermentation, the byproduct of that is lactic acid, lots and lots of lactic acid. People, everybody knows this from the fermentation process making beer. That's ultimately what happens with beer. And we have fermented foods and all those kind of things. We understand that process is we take away oxygen and then the bacteria ferments. But this is what the cancerous cells do. Now, in this process, it's only making about 4 units of ATP. A normal cell is usually making about 36 units of ATP. So we got a stark decrease in energy output. A stark decrease in energy output here. Another thing that happens is that in this state of survival mode, a little coat goes around the cell. It's called a fibrin coat, a CD47 fibrin coat. And the, the, the thing about this fibrin coat is that it actually makes these cells invisible to the immune system. So the immune system is, these little police guys walking around and they're looking and they're monitoring cells. And if they see a cell that's out of step, they go and they eat them up and make sure that everything's okay. In a cancerous cell, this fibrin coat surrounds it, and the immune system walks right past it. So that's another reason why it's so difficult for the body to kind of keep up there. Now, in this slide, this is where we start to expound a little bit more on the vicious cycle of a cancer cell. Okay. So we talked about how the mitochondrial DNA gets damaged, sends a signal to the nuclear DNA, and then the cell turns into survival mechanism. Now, what happens in the extracellular matrix, so around the cell, is that you have lactic acid that like I talked about earlier, but also the cell secretes these things called exosomes. And these exosomes will recruit other normal cells to become malignant. They also secrete cytokines. And these cytokines will increase inflammation and it will inhibit natural killer cells, which is part of the immune system. So you got the fibrin coat that makes it invisible. You got inhibition of these natural killer cells, which will further suppress the immune system. And then you also have these things that will create what's called tumor-associated macrophages. Now, the macrophages are the little Pac-Man guys that go around and they eat away all the cells that don't need to be there anymore. It takes care of pathogens. Tumor-associated macrophages, they basically switch teams here. Okay? And now they work on the side of these cancerous cells. They increase new blood vessel formations by increasing what's called angiogenesis, and it suppresses the immune system. Pretty crazy stuff. Now, also what happens in the extracellular matrix is that toxins will build up, and then there's these things called pleomorphic bacteria. And within your blood, you actually have microbes that live there. The blood is not actually sterile. And given the right conditions, these pleomorphic bacteria will actually change its shape. Pretty crazy stuff, which will further become actually pathogenic to the cell, which will further attack the mitochondria. Now, here's an interesting thing is that these cells will create more lactic acid. The lactic acid will go to the liver, and the liver will actually turn the lactic acid back into glucose. And cancer cells actually have 1,000 times more insulin receptors in it. That's its main source of fuel. That's what it ferments. So it takes that glucose that's been made by the abundance of lactic acid that's secreted by the cell, and it feeds. So it's this vicious cycle that keeps feeding itself. So the more cancer cells are produced, the more lactic acid, the more glucose is made, even if you're not taking in glucose. And the cycle just keeps building up. So you guys kind of see why it's so difficult. And before I get any further, I want you guys to realize that this response is a survival response after prolonged assault to the cell. So your cell is just doing its job to stay alive. That's all that it's doing. Now, I just talked about pleomorphic bacteria in your blood because a lot of people think that the blood is sterile. You can read this article in the Journal of Clinical Microbiology where they actually show these bacteria in the blood of healthy humans. All right, let's get into the phases of homotoxicosis. All right. So what happens is that toxins will enter into your body and it will go through these 6 different phases. Say the first 3 are extracellular, and it goes through excretion, reaction, and deposition phases. Okay. This is outside of the cell, and your body is doing whatever it can to get rid of the cell, whether you had vomiting, diarrhea, inflammation, to burn it off. or it'll be deposited and tucked away into the connective tissues. Okay. It's trying to just get it away from the cell. Now, once all of that stuff builds up, then it starts entering into the cell, and we start entering into the next three different phases: the impregnation, the degeneration, and neoplasm. Okay. So the impregnation phase, the toxins, they cross the cellular barrier and they start messing with how the cell functions. Okay. Now you get a whole bunch of cells that's not functioning properly. You get an organ dysfunction. Okay. And when you have an organ dysfunction, cellular energetics are damaged. The cells begin to ferment because they need to make energy and survive. And that's when you got a full blown neoplasm or cancer cells. So the body goes through these different phases, and it's doing its thing when it's trying to survive. Now, if we look at the symptoms here, right? Vomiting, diarrhea, inflammation, connective tissue deposition. Um, these look like symptoms that the medical profession usually tries to stop. A lot of us don't like these things, but it's our body's natural way of getting rid of stuff. So whenever I'm working with patients, I'll encourage inflammation. Fevers, by the way, is a real helpful thing because your body's just trying to get rid of toxic assaults. Vomiting, diarrhea, all of those things is just your body trying to get rid of stuff. Because you want the stuff to stay outside of the cell. You don't want it to mess with the cellular function. Okay. Now, what's the immune system's role? Well, if the immune system's high, cancer cells are low, you're in good shape. Okay. The immune system's role is to keep the cancer cells at bay, and it does its job. Every single body on this planet has cancer cells growing all the time, just because of DNA changes do affect. You got mitochondrial changes. You got all these things that's happening. Now, if the immune system's healthy, functioning, your body takes care of it. It's when the immune system is suppressed, cancer cells increases, that's when the body just can't keep up. So the goal here is to mitigate all of the things that suppress the immune system and mitigate the things that's causing cellular damage. Okay. Now the question becomes, and this is a very common question I get from people, is, well, what about cancer genes? Cancer runs in my family. I've been tested. I have all these different cancer genes. The BRCA, all of those things, right? I mean, Angelina Jolie, she tested positive for the BRCA gene, and then she got a double mastectomy as a preventative measure. Well, what about all of those things? Now, yeah, genetics does play a role, but does it play a big role? Not really, right? Only about 5%. So genetics is only playing about 5%. The other 95% is lifestyle, right? We know these things, but we tend to point the fingers at things that we don't want to take responsibility for. And that's a big issue. Okay, and we'll get into that as we talk further along. So if it's not necessarily just the genetics and its lifestyle, what is that? Well, we call that epigenetics. These are the different things that affect the genome. And these are the different epigenetic classes. You got toxins, parasitic organisms, allergy sensitivities, nutrient imbalances, and stressors. What does this all do? Well, they have an impact upon the mitochondria, which the mitochondria, if it's damaged, sends a signal to the nuclear DNA, which activates oncogenes. And the epigenetic factors also impact the nuclear DNA directly. Okay. So now you may have heard of things called methylation, histones, the epigenome, the genome, and all this stuff. I mean, the way you look at it is kind of like a computer. Okay, you got methylation factors which act like switches. Okay, they switch things on and off. They activate genes. Histones are knobs. They kind of turn things, and they gradually activate different parts of the genome, turn things off. The epigenome is the software. Okay, this is the software that creates activity, and the genome is just the hardware. Okay, there's nothing you can do about the genome, right? There's nothing really that you can do about that, but you can affect the epigenome, you can affect the methylation, you can affect the histones. You can affect the things that are creating changes in the hardware. That's where the focus should be. And unfortunately, that's where a lot of the cancer research has not been focused on. And that's why we have not been winning the war on cancer. Now, the other facet of this is it's really difficult. I mean, it's not something that, okay, we know those things and we can just, you know, eat a berry or something like that and everything will be well. It's not that simple, right? Because there's so many different factors. And what I always tell patients is that cancer is not a single disease, it's a multi system breakdown. We're looking at almost every single system of the body. It's not, if you have lung cancer or if you have colon cancer, whatever, wherever it manifests, it's a multi-system approach. And unfortunately, the way that the oncological fields have looked at treatment, and we'll talk about that a little more, doesn't really address causative factors. Okay. Now we talked a little about histones. Histones are these little balls. I think that's what they look like. That your DNA wraps around. So it's kind of like it helps to pack your DNA into the nucleus, because if this didn't happen, everything would just be a jumbled mess and it would be too big for it to fit in there. So it wraps around these histones and it makes everything nice and tidy. But another thing, these histones, what they do is they're activated by certain enzymes, and these enzymes will cause the histones to unravel the DNA that's wrapped around it. And when that happens, then the DNA is now exposed for replication, but it's also exposed to assault. So if the DNA is wrapped nicely and tightly around these histones, it's very difficult for assault to happen. But if you have something that affects the histone to unwind when it's not supposed to, then you're exposing the DNA to assault when it's not supposed to be exposed. So there are a few things that can actually mitigate these enzymes from unraveling the DNA around the histones at improper times. You got things like resveratrol, pterostilbene, curcumin, chalones, and flavones. These things affect those enzymes that cause the histones to unwind the DNA. Okay. So if your diet and lifestyle is deficient in those things, maybe the enzymes will actually unwind the histones at improper times, and that's when you're gonna succumb to more of the epigenetic assaults. So the question is it genetic or metabolic? It's both, guys. It's both. And I hear the arguments from both camps, the genetic and the metabolic camps, and they're both right. And I often wondered, why are we even having that argument? Right? They're both affected, and we need to address all aspects. Now, in cancer research, they came out with this ideology of the hallmarks of cancer, right? So they said, well, what does a cancer cell do? All cancer cells exhibit these characteristics, right? They sustaining proliferative signaling, right? The signals make the cells proliferate, divide uncontrollably. They evade growth suppressors, right? So there are specific suppressors for cellular growth that cells are supposed to obey. These guys don't. They just keep growing. Activating invasion and metastasis. So they go in and they just spread wildly, enabling replicative immortality. Okay. Inducing angiogenesis, so formation of new blood vessels. So now what happens is that when these cancer cells divide rapidly, they form tumors. What they do is it signals a stress response, and the way that the body responds to that stress response is it says, oh, look, there are cells that need more nutrients and need more oxygen. So they create the body creates more, or I should say, new blood vessels to that area. That's when you got issues there. Okay, so inducing angiogenesis, resisting cell death, reprogramming energy metabolism, and evading the immune response. So essentially, cancer cells grow rapidly. They don't obey the laws of not stopping in growth. The immune system can't see them, and they change how they make energy. That's basically what a cancer cell is. When the current medical model uses basically 3 modes of treatments: chemotherapy, radiation, or surgery. Has that been effective? Well, there was a study, and there's some controversy around this study, where they found that the curative and adjuvant cytotoxic chemotherapy to a 5-year survival rate in adults was estimated to be 2.3% and 2.1% Australia and United States. So basically saying that only 2 to 2.5% of the people actually survive by undergoing chemotherapy. Now, I think that that's a little bit low. I think it's on the higher end, but I'm in agreement with that. The institution of chemotherapy, radiation, and surgery really hasn't done much for the increase of survival rate. And the way that they measure survival rate is a 5-year mark. So if you've gone past the 5 years, that's considered a successful cancer intervention. So you could have gone 5 years and 1 day and died, and that would still have been a success. In my opinion, that's not. So the effectiveness of treatments of prolonging life, say, maybe like I said earlier, maybe the lifespan initially was like 18 months from diagnosis, and they increased that to 2 to 3 years, then that's considered a success. In my opinion, that's not. So what does the chemotherapy really do? Well, the majority of them, they either block hormone receptors or they stop the cell from dividing. Essentially that's what it's doing. It's trying to halt cellular division. And that's why you see in chemotherapy interventions, you see people lose their hair, nausea, because the cells in the gastrointestinal tract stop dividing, and you don't get any new cells. So that's basically what's happening with chemotherapy. Now, I always say this to patients. I say, chemotherapy is 100% effective at what it's designed for, which is to stop cellular division. It's 100% effective. Problem is, it's non-selective. So you are wiping out the cancerous cells along with normal cells. So it's like going into a town that has 100 terrorists, but the town has 500,000 people, and you drop an atomic bomb. The atomic bomb doesn't just target the terrorists. It targets everybody. And that's the issue with chemotherapy. It does its job, but it does its jobs too well. So the trick behind our modern day oncology is to kill off the cancer cells before you kill the patient. That's what all oncologists are taught. We got to use the dosage that will be just enough to kill the cancer cells, but not kill the patient. Unfortunately, that's not really successful most of the time. As we can see in the studies, about 97% of the time, not that effective. Okay? But the chemotherapy doesn't do anything to address the mitochondria. Now, let's look at this. One of the other issues is that when you do use stuff like chemotherapy, it's another assault on the cell. The thing about the cell is it's all about survival. So it creates resistance, actually. Right? And what happens is that a lot of the cancer patients that I see that undergo chemotherapy, they have a relapse. And I'll talk about the relapse in a couple more slides. But what happens there is that the cancer cells, they form a resistance, and because they're trying to survive. So now you try to use the same chemotherapy on it, and it doesn't work. Okay. Unfortunately, I'm going to show you a couple more slides here. This is the standard of care that we're seeing in most places, right? And I found this discussion on one of the cancer therapy threads here. And this person said that is exactly what my oncologist recommended I eat: hamburgers, French fries, milkshakes. And the rationale was that she wants me to drink sodas and eat garbage to gain weight. And that's what we see with a lot of oncologists. They're more concerned about the rapid weight loss because the body's burning through, muscle tissue, because it's another form of energy. Unfortunately, if we look at that, that's what the oncologists are recommending. Here's what a oncologist dietary recommendation here. This is from a cancer dietitian, and they write, eat like a kid, seriously. Think of kid-friendly foods, which are often high-density, calorie protein-rich items in a small package. Ice cream with bananas, chocolate syrup, caramel, and sprinkles. Milkshakes. These are the things that are being recommended to cancer patients. Okay? So now why do reoccurrences occur? Well, the cancer cells that we see is like a weed. But unfortunately, what the modern treatments of chemotherapy, radiation, and surgery, what they never address are the cancer stem cells. That's the more difficult thing. The cancer stem cells is like the root of the weed. So you can spray all of these, cancer weeds, but if you never get to the root cause of it, it's going to occur, or reoccur, I should say. And that's when the reoccurrence becomes the bigger issue. The primary cancer is highly, highly manageable. And by the way, before I get even further, a lot of people, a lot of studies, I should say, have shown that a lot of people can actually live a long, healthy life, by the way, with cancers. They've done autopsies, and they've shown that a lot of people actually have undiagnosed tumors. And that's another thing that I think is an issue in our country, is the overdiagnosis of these cancers and the quick to go through these treatments. And those the treatments in and of itself become carcinogenic. All right, what are some of the common tests that are done? Well, we got the colonoscopy, CTs for, looking for lung cancers. We got mammograms looking for breast cancers, pap smears for cervical cancers. We got the CA-125, breast cancers, PSA for prostate cancers, and then the good old biopsy. Okay. The problem with common testing is that it shows you, and even if they say it's preventative, it's really not, because it shows you after it's developed, right? And then a biopsy, by the way, in my opinion, from what I've seen, is not really an effective thing, right? There was a study, and then the studies were showing that, it says cancer cells, besides reproducing uncontrollably, lose cohesiveness and orderliness of normal tissue, invade and get detached from the primary tumor to travel and set up colonies elsewhere. Now, what happens is that the body forms these little colonies, and it segregates it. Okay, it puts a wall around it, almost like putting these cancer cells in prison. Now, once we start breaking that wall in the prison, these cancer cells actually will dislodge. It says tumor cells are easier to dislodge due to lower cell-to-cell adhesion. And what they do is you get this seeding effect. So it's almost like you're getting a weed and you're just spreading the seeds. And I found that to be true with the majority of the patients that I've seen. They've gone in for, they may had some type of tumor that they felt, and it's seen on a scan, and then they go and disrupt it, with a biopsy, and then soon after that, we see massive spreading. Now there was this study that was done. It says, well, no, cancer biopsies do not promote cancer spread. And I looked at this because, I'm like, well, I don't know. Let's see what the studies say. And a lot of these studies that try to show that biopsies do not promote the spread of cancer, they look at pancreatic cancer. Now, the problem with this, there was a couple issues that I saw with this study. Is that one, they showed that the survival rate between the ones that had the biopsy versus the ones that didn't, the ones that had the biopsy was longer. They survived longer than the ones that didn't have the biopsy, which, correlates with their claim here. But the survival rate was only like 3 months longer. Okay. That was the big, like, okay, well, that doesn't seem like a significant difference there. Second part is they studied pancreatic cancer. Now, there's a big thing with pancreatic cancer. Pancreatic cancer, by the way, if you biopsy it, this is not the one that you want to study for biopsy, because the pancreatic cancers, you're not going to get a long survival rate anyway. And the issue with pancreatic cancer is pancreas is the one that secretes the enzymes that will eat away at that fibrin coat that cloaks these cancer cells. So to study pancreatic cancer in relation to biopsy on how that affects doesn't seem like the best way. Now, all the patients that I've seen with breast cancers that have had biopsies all have had metastasis. Same thing with lung cancers. Now, let's see, colon cancers were like a 70%er, 75%er, but the main ones were breast cancers and lung cancers that as soon as they did the biopsy, boom, it spread. And also with the 70% on the colon cancers, what happened was when they did the biopsy, it now spread to the outside portions of the intestines called the peritoneal cavity. And that's when things became an issue. Okay. So I've seen it firsthand clinically from direct patients. Now, there are advancements in testing. One is liquid biopsy, and you can request that. And that's, in my opinion, that's a more viable way, a less invasive way of looking into the body and seeing. Okay. All right. Now, with that said, this is the basic cancer protocol that I've used with patients. Now, by no means is this comprehensive, because every single case is individualized. So whenever I work with a patient, I have a blank slate that I start with. I have I have a protocol in mind, but I also got to look at the patient, what they're going through, what they've gone through, where is their constitution. We got to take into all of these things into account. So that's kind of what's going into my mind. The patient comes into my office. They've had a diagnosis of cancer. I sit down with them and I look at what tests they've run. Now, the reason why I look at the tests they've run is I want to make sure that we got a definitive issue here. I have caught cases in the past where they've been given a diagnosis of cancer and it was not. And a lot of times what happens with oncologists is they'll diagnose it and then they'll move forward with a treatment plan of either chemotherapy, radiation, or surgery as a knee-jerk reaction. And a few patients we've caught it where they were misdiagnosed, and had they gone through with those regimens, they may have ended up with some type of other health issue. They've done studies to show how many cases were misdiagnosed, and it's alarming. So I haven't seen the latest research on that, but anyhow, this is the protocol that I use with patients, right? We got to look at the entire body. Like I said, cancer is not a single disease. It's a disease of multiple systems, if not all the systems of the body. So the goals of the entire protocol, this is what I always have in mind whenever I work with patients, is we want to optimize the voltage of the body. Okay, the body's electric, so we got to make sure that the electrical activity of the body is at its highest level. We got to improve circulation. We got to increase the body's temperature because cancer cells does not like high temperatures. We got to stabilize glucose levels because that's its main source of fuel. And then we got to flood the tissues with oxygen. It does not like oxygen. But the first place we always start off with is supporting the mind. Because if their mindset is one of defeat or I've already died, there's no sense. So whenever I sit with a patient, I always ask them, what is your purpose? Do you want to live? Or have you bought into what they've told you? You know, if they said, hey, you got 4 months to live, do you buy into that? If they say, I have no purpose, I just want to die, it's too hard, in my opinion, there's not a thing on this planet that's going to help. Okay. So if they already have the mindset that they're done, then they're done. Now, if they say, oh no, it is what it is, we're going to do whatever it takes, then we have a really good shot. Okay. So the whole goal with mindset is we want to create and know what the purpose is. We want you to have a purpose in your life. What's worth living for? Okay? And then we create benchmarks along the way. And then along with the benchmarks, we plug in the protocol, and that's the action steps that you take. And then we use the benchmarks to see if we're on the right track to accomplishing your purpose. It's very simple, but the most difficult thing to do. This is the most difficult thing about the treatment process because you don't feel good. You go into your medical appointment, you get diagnosed, and there's a lot of fear that surrounds that, a lot of uncertainty, and I understand that. So I sit down with the patient. We got to make sure, hey, do we have a plan in mind here? Do we have a reason? What's the vision and your purpose in life? That's where we always start. Then we got all of the protocol tactics is to support the mitochondria because that's the biggest factor in all of this. So these are the big ones. I know I'm going to list the big ones here that support the mitochondria. Biggest one, intermittent fasting, okay? Resistance training, abnormal blue light exposure, we want to mitigate that. Abnormal EMF exposures, we want to mitigate that. And then we want to supply the nutrients for mitochondrial health. And here's your listed nutrients there, okay? How do you do a 16 to 8 intermittent fast? That means that you're fasting 6 hours out of the day and you have an 8-hour eating window. Very easy. If you have your first meal at 12, you stop eating by 7, 8 o'clock, and then you fast from 8 all the way to 12. Very easy. If you really want to get your mitochondria even healthier, you compress that even more. So a 20-hour fast and a 4-hour eating window. And then you can do resistance training because what you want to do is you want to build muscle. And the more muscle that you build, the more mitochondria you build. Okay? So resistance training, whatever you got to do for resistance training, 3 to 4 times a week. Very simple. And then mitigating blue light exposure. Oh, by the way, I'll put the links to all of this in the bottom section here, so you guys can have access to the things that I recommend. Now, mitigating blue light exposure is very easy. Turn off your lights when the sun goes down. Use blue blocking glasses or use the night shift mode on your LCD or LED devices because abnormal blue light exposure is messing up your circadian rhythms, will actually suppress mitochondria function in your body. Now, this is one of the big ones that most people, this is where they start. Okay? They want to know, well, what do I eat, doc? What do I eat for this condition? What do I eat for cancer? Whatever. So every single one of my patients that is going through cancer, we put them on a ketogenic paleo-like diet. Okay, a lot of research surrounding that because what you want to do is you want to cut off the fuel supply to those cancer cells because cancer cells have 1,000 times more insulin receptors they're not efficient at using fat for energy. So usually what I'll do is we'll put you on a 75% fat-based diet, 15% protein, and 10% carbohydrates. If you monitor your blood glucose, you want to keep your blood glucose below 70, and if you measure blood ketones, you can buy these monitors. You can buy them on Amazon. You want to keep your blood glucose at 70 and blood ketones at 3.6. You also want to make sure that you're supplementing with these minerals, selenium, magnesium, and potassium, because those are depleted when you go through a ketogenic diet. Now, with that said, you got to understand that dietary measures, these are for a clinical response. I don't necessarily recommend this as a lifestyle, as a general lifestyle. Some people do utilize this. I don't agree with that because you're depleting a lot of minerals. Okay. So, how do you calculate all of this, right? What does that look like? The average person is going to need about 2,000 kilocalories per day. So, if you're utilizing these percentages, you're going to be trying to get in about 165, 166 grams of fat, 75 grams of protein, 50 grams of carbohydrates. Okay. I'll list below the different types of macro sources. The one I want you to really stick to are the proteins: grass-fed pastured meats, free-range poultry, pastured eggs, wild-caught small fishes. Okay. Those are very important. Why? Well, because that's what your immune system is made out of. Actually, that's what the majority of your body is made out of. You need really good protein sources. Now, your fats, you got your avocados, you got your nuts, all that stuff. But you can kill two birds with one stone here by utilizing pastured eggs, wild-caught small fishes, because that's going to satisfy your fats, omega-3s, and it's going to satisfy your protein needs as well. Okay, carbohydrates are mainly going to be your starchy vegetables. Okay, so you guys can look that up, or you can look at the list I put on the bottom. Okay, this is the one of the most common questions I get from people as well. How do I establish circadian balance? So there are three major aspects to your circadian balance: your sleep-wake cycle, your eating cycle, and your movement cycle. Okay, really easy, guys. When the sun's up, you get up. When the sun goes down, you go down. Okay, that's your sleep-wake cycle. Your eating cycle will be your largest meals primarily in the afternoon. Smaller meals are bookending on your days. So small breakfast, large lunch, small dinner. And then your movement is going to be more strenuous movements in the afternoons and lighter movements in the morning and all throughout the day. A lot of people are doing their more strenuous activities right when they get up, and you don't want to do that because you are throwing off your circadian balance. And this is just because of years and years of human evolution, of how we work with our natural environment. Right? If you were in a hunter-gatherer society, which we all came from, as soon as the sun got up, you got up. And then you walked around, you looked for something to eat. It's not like you had a refrigerator that you could go to, right? So you walked around, hunted, you gathered, maybe you found something, okay? You found something, you had a large meal at the mid part of your day. And then what happened was you were away from camp, so you had to walk back. So you hunted, you found it, you ate it, and then you had to carry it back. So you had a lot of strenuous activity towards getting back to camp towards the end of the day. And then by the time you got back to camp, you maybe had something else, like a small little, I don't know, shrubs, berries, and then you went to sleep. That's how our bodies were entrained. That's the exact opposite of what we do today. All right. Now, the first step that we got to go through is your gut repair. So if you haven't gone through the Total Gut Restore program, go through it. But this is essentially it in a nutshell. Got to restore nerve communication, remove the stuff that doesn't need to be there, replace the stuff that should be there, reinoculate the microbiome and then repair damage to the gastrointestinal wall. Okay. Now, alongside with repairing the gut, we got to make sure that we balance the pH levels, because repairing the gut, balancing out the pH levels is going to influence how well we absorb the nutrients that we're eating. Okay, you need the nutrients for cellular repair, cellular detoxification, but if it can't get past the gut, it's useless. Okay? And also for pH balancing, it's also very essential for healing, right? Robert O. Becker wrote a book called The Body Electric, and what he found was that salamanders, they can heal and regenerate their limbs. And the only way that they do that is through a process called a healing crisis. And in that time, the body will switch its voltage or increase its voltage to heal the tissues. And whenever you get an increase in voltage, it's also correlated to an increase in pH, right? So pH is the more alkaline something gets, the higher the level of electrons, right? We know that with batteries. Batteries are alkaline batteries, and when you first use batteries, they have a lot of electrons. It's highly alkalized. And when you use up the electrons, it becomes acidic. Okay? Very, very important for you to know. So how do you monitor this? Well, it's easy to do with salivary or urinary pH. You just get pH test strips and you measure that. You want to be above 7. Okay? For most cancer patients, we want their millivolts to actually be around 75 millivolts, and that's about a pH of 8. Okay, so salivary pH is going to be about 0.08. 0.8 units less. Okay, so for cancer patients, I want your pH about 7.2, about there. That's usually the realm that I want to see your pH levels at. This is what I use to alkalize patients really quickly. I also put a link to the video below that further explains what this does. There's a lot of research that surrounds how pH affects. Remember, I said that in the extracellular matrix, the pH is actually more acidic because of the buildup of lactic acid. And the buildup of lactic acid is going to create more glucose because it goes to the liver. So if you buffer that lactic acid in the extracellular matrix, then you decrease the amount of glucose being made by the liver. You also will decrease you'll increase, I should say, the amount of oxygen being delivered to the tissues, because in acidic solutions, oxygen doesn't dissolve as easily. Okay, so now we've got the gut, we've got pH balanced out. Then we want to start opening the channels of detoxification. We haven't even gotten to detoxification yet. See, that's where a lot of people actually want to start. They want to, hey, what can I, what smoothie or whatever can I drink to detoxify the body? Well, no, you got to do the gut first. You got to make sure that the pH levels are balanced. And then you can start opening the channels of detoxification. Because if the channels aren't open and you push the body to detoxify, it's just going to back up and you're going to auto-intoxicate. You're basically going to reabsorb the toxins that's already stored in your body. So remember, toxins are stored within the connective tissues and within fatty tissues. And if you do not do this properly, you'll make things worse. So these are the channels of detoxification that you got to open up. Again, gut, kidney, bladder, lungs, skin, and also emotions. We don't talk about that a lot, right? But you have what's called these neuroemotional complexes that become toxins. If you read Candace Pert's book, Molecules of Emotion, every single thought will create a corresponding neuropeptide. And these neuropeptides will float around and will create physiological reactions. So if you have the same type of emotional response, you're creating a lot of the same types of neuropeptides, creating the same types of physiological changes. So you got to change those thoughts to change physiological output. This is what the cells look like. A lot of times we just think that these cells are floating around, but they're actually embedded into this fibrous tissue network. Now, what happens here is that if these fibers become too rigid or non-elastic, you don't get nutrients that will flow in and the toxins can't go out. And then the cells become unhappy, right? You create what's called structural rigidity. It starts with postural faults or any type of physical trauma. And what happens is that if the body is put into these different postural faults, tissue thickening will occur along those lines of tension. And this is just the body's natural adaptation to those faults because it has to keep up with the demands. So if there's an improper amount of pull on your tissues, the body responds by making it more rigid, right? Okay, so what happens there that the fascia thickens, the muscles surrounding the area become inhibited and trigger points will form. So you get chronic pain syndromes. And then you have what's called increased thixotropy. This means that the tissues won't be as supple, right? The tissues start to harden. And when the tissues start to harden, you don't get enough oxygen delivery, you don't get enough nutrient delivery, and you don't get enough toxin removal. And what happens when you do that? The cells respond. And they ferment for energy and they turn cancerous. So, what do we do there? Well, when we look at these tissues, we got to make sure that we're keeping our body, one, posturally correct, and two, our tissues have to be supple. This comes with just general movement, and then also making sure that we are getting those collagen fibers to elongate and keeping those tissues supple. You can do stuff like foam rollers, you can use stuff like massage, all of those things that affect, or called body work. Chiropractic is a big one with that. Okay? Making sure that we are addressing emotional issues as well. Here's a study that they did showing how the matrix stiffening is promoting tumor vasculature. Pretty crazy. So what they found was that when the tissues surrounding cells become hardened, this will create a lot of cancer cell development. Pretty amazing stuff. All right, the next part is clearing the blood. I want you guys to go look up the Bob Beck protocol. Not specifically everything, but specifically the blood electrification. There's a bunch of different devices. And remember I told you about the pleomorphic bacteria in the blood. Well, you got to clear the blood. And what happens is you start using these things. There's one called a pulsar, but you guys can go and look it up. And what happens is that you will electrify the blood, you will neutralize a lot of these pathogens, and you'll feel really sick. Okay? Especially if you didn't open up the channels of detoxification. Got to make sure the gut, the kidneys, lungs, skin, all of those things are flowing well. Then you got to make sure that the tissues are flowing well. And then we can start doing the blood electrification and clearing out the blood so that we can deliver oxygen and nutrients effectively, and we're not delivering the toxins from the pathogens within the blood. So the Bob Beck protocol is very, very essential. All right, the next pillar is addressing oxidative stress. So the mere fact of you being alive and breathing oxygen and eating food is that you're making what's called reactive oxygen species. Okay, so the byproduct of your mitochondria making energy is these hydroxyl free radicals. Now, the free radical is basically missing an electron. It's not happy. It needs another electron. So it goes and it scavenges for an electron and steals from a happy bonded electron pair. When that happens, it creates a cascade of effects because now the one that it stole from doesn't have a paired electron. So it goes and looks for another electron and down the line and down the line. So what we use is molecular hydrogen. And what molecular hydrogen does is it supplies the missing electron, and the byproduct of that is it makes H2O. Okay? In cancer cells, you have an abundance of oxygen radical species here. So molecular hydrogen, because it's so small, can diffuse all the way past the cellular membrane, all the way past the mitochondrial membrane, into the mitochondria, into the electron transport chain, to curb all of these free radical oxygen species there. Pretty cool stuff. Next one is you want to balance the stress response. Stress is a huge factor, especially you got a diagnosis, your body's going haywire. Now, if you are in fight or flight mode, your body cannot heal. So in your autonomic nervous system, you have two parts. One is the sympathetic, which is the fight or flight, and the other one is the parasympathetic, which is the healing mode. If you are in fight or flight, you cannot digest, you can't detoxify, your immune system is suppressed. So if you are in that mode and going through cancer issues, you're never going to get out of it if you don't curb the stress response. How do you monitor your stress? Well, measuring your heart rate variability, okay, using a chest strap monitor, and using an app like NatureBeat to monitor your stress levels, and then you can see where your stress levels are at. There's nice little colors that'll show you. If you're in the yellow or red zone, that's bad. If it's green, you're good. You can do things like meditation, adaptogens, and using things to regulate the HPA axis. This is your stress response axis. Okay. Basically, you put on the chest strap monitor in the morning, monitor your stress levels. Anytime you feel stress, put the chest strap on, see where you're at, and then you can do things to mitigate your stress. And what you start doing there is you start training your brain how to respond underneath stress. And then your brain and your body will respond according to that. Okay? Very important. Blood sugar balance is also another big one because sugar is one of the main sources of energy for fermentation. So we use a lot of exogenous ketones and intermittent fasting. Very simple. And if you're doing the correct diet, you're going to be balancing this out as well. Big one here is curbing inflammation. Now, the reason why you need to curb inflammation is in the state of inflammation, you are also in a state of acidity, which means that you have low oxygen delivery, low detoxification, and decreased circulation. So you want to curb inflammation. Big things like frankincense oil, proteolytic enzymes, and omega-3 fatty acids, those are my big three for curbing inflammations, along with balancing out your pH levels. You also want to support the immune system. Medicinal mushrooms, which have beta-glucans like chaga, probiotics to stimulate the balance of the microbiome, which influences the gut-associated lymphatic tissue, and also liposomal vitamin C. I'm going to give you guys the list of supplementation that you can fill in the gaps with for your diet. Okay, so I already gave you guys the basic dietary template. Remember, these are just templates. Everyone has to be an individualized case. You also want to support or recorrect cellular messaging because you got a lot of improper cellular messaging. Your insulin levels are all wacko. Leptin is totally wacko. Estrogen's too high. Progesterone's too low. Testosterone's too high. DHEA actually may be too low. You got the secretion of exosomes, which is recruiting normal cells to become cancerous. And then cytokines, which influence the inflammatory response. You also got that aromatase enzyme, which is what a lot of the breast cancer drugs is trying to block, right? Trying to block the creation of these estrogenic compounds. So you got to look at all of these things and correct those. Everything that I just listed before and the protocol that I'm going to show you guys coming up will address these. All right. And then filling in nutritional deficiencies. Sometimes because the gut is damaged, you will need an IV nutrient delivery. And this shouldn't be a long-term thing, just a short-term thing, just to kind of give your body the nutrients that it needs. Because when you're ever in a state of nutritional deficiency, your body just can't work properly. And then the big one here is emotional and spiritual balance. Using things like emotional freedom technique and clearing emotional blockages. So these are the major acupuncture points that I recommend for clearing emotional blockages. And what these do, I usually recommend tapping these points about 4 times per year, is that it cleans out the gutters, cleans out all those emotional gutters in the meridian system so that your body can naturally deal with the emotions that you're experiencing. And then the picture on your left there is your thymus. And what you can do is what's called a thymus thump. You just basically just take your fist and then pound on your chest, kind of like Tarzan. Not too hard, but just enough to just thump on your chest. That activates the thymus gland, which is part of your immune system. Now, this is the healing process. Goes through 3 major phases. First phase is the removal. We got to get rid of all the stuff that doesn't need to be there. Then we repair the damage, and then we restore, right, the nutritional deficiencies. So the removal phase should last anywhere between 6 to 9 months. The repair phase about 6 months, and the restore phase about another 6 months. So it is about a 2-year program for your body to get back to where it needs to be. Okay, because you got to remember, your body has like 37 trillion cells that are all in either alignment or disalignment or disarray that we need to get back into coherence. Your body's like a big symphony, and we need everybody playing the same piece at the same time, at the same volume. Or some need to be at their volume while others calm down in volume. Okay, so it's all about a balancing process here. Now, for most people, this is also dependent upon the severity, aggressiveness, the state of your immune system, your current constitution, which is your mindset. An integrative approach is the best, especially if it's really more aggressive, where you need to use synthetic chemotherapy, radiation, and surgery. But I don't think that you should be using that alone. You need to support your body with natural chemotherapy agents. Everything that I'm talking about is natural chemotherapy, electrobiology, and nutrition. You got to support your body because you're getting an assault. So you got to support the body while it's breaking down so you can build it back up. That's why I always say an integrative approach is the best. And for my patients that have had more aggressive types of cancers, we've always got way more success with an integrative approach. A lot of the people who've just done what they consider a natural approach and never did an integrative approach were not successful. Now, there were some cases where they already went with just the traditional approach of chemotherapy, radiation, and surgery, and their body just was not responsive to that. Okay, so all the things that I talked about here will always help the body to build itself up. But if the immune system can't respond and the body can't absorb the nutrients and deliver the nutrients, it's almost useless. So we got to use all the things that I listed in the protocol here. Okay. Now, this is what I tell all my patients whenever they work with me, right? You got to be committed to your health. And typically what it looks like on in-office treatments is about 2 times per week. Some may need a little bit more intensive care. And then at home, you're going to be doing your own things, whatever things we give you to do at home. And this is what a typical patient, what I'll tell them and what their program will look like. There are the rules for healing. I always tell every single patient, there's no dabbling. You got to pick one thing. You got to have your mindset on healing. Okay? You don't want to be dabbling and thinking, oh, maybe I'll try this and maybe this will work. You got to be focused on one treatment round. You got to have a positive outlook on your program here. Okay? A lot of times people want to focus on, I want to cure my cancer. Well, first of all, it's not your cancer. You're experiencing cancer and you don't cure it. You take away the environmental factors that the body is responding to that is displaying cancer as a survival mechanism. It's a way different mindset and approach. You got to focus on healing. It's kind of like you go into a hot room and you start perspiring. Why would you ever take a pill to stop perspiration? Just get out of the room that's hot or turn on the AC, right? Make it cooler. Change the environmental input so that you get a change in the cellular output. You always want to keep your appointments that you make, be committed to that. Commit to your nutrition, commit to your lifestyle, commit to learning about how your body works. Now, whenever people come into my office, this is the flow of what we do for them. Okay, we'll start them off with pulse electromagnetic field therapy. We'll use oxidative things that will help re-establish the folding of proteins, and meditation. After they go through that round, they go through a next round of electrobiology, infrared sauna, and oxygen therapies. And then we start working on the physical structure. We work on the body. We make sure that the tissues are pliable so that we can get cellular movement. We work on emotional blockages. And after we do that, then we work with molecular hydrogen, another round of pulse electromagnetic field therapy, lymphatic drainages. We use ionic foot bath to pump in more electrons into the body, and then photobiomodulation with red light therapy. And we do these things to deliver more electrons, deliver more nutrients, oxygen, and get rid of the things that does not need to be there. All right, here's your supplementation list. Okay, it's pretty comprehensive. Looks like a lot, but it's not. These are all the things that your body needs. I mean, there's actually way more, but these are the ones that I feel and have seen that you get the best response, and you're not spending $4,000 on things. Transdermal magnesium. Okay, so this is stuff that you rub on your body. That's what transdermal mean. Alkalite iodine. Okay, iodine, you're going to be getting your body up to 12.5 to maybe 50 milligrams. So if you're using the nascent iodine or the liquid iodine, that's like 6 to 8 dropperfuls, not drops, the entire dropper. So 6 to 8 of those. Selenium, and then we're using what's called a detox cocktail. CBD oil, about 40 milligrams per day. Vitamin D3 is very, very essential. And vitamin D3 and water hydration goes hand in hand, because in order for your body to make active vitamin D from the vitamin D you produced it from your skin, you need to be well hydrated. Okay, so there are certain things that we do with hydration that I'll have listed below. I also recommend a greens drink, proteolytic enzymes, which helps to eat away at that fibrin coating around the tumor cells. And then there's different types of medicinal mushrooms like fucoidan, chaga, reishi, turkey tail, shiitake, maitake. I have a blend that we use as well to help with supporting the immune system and a broad base of medicinal mushrooms. And then we're using things like trace minerals, molecular hydrogen, and exogenous ketones. So this is the list that I use. It's not a lot. It seems like a lot, but it's really not a lot compared to if you look on a lot of other practitioners that make you buy like $4,000 worth of supplementation. Now, if you're undergoing radiation, these 4 things are a must. You got to have something with resveratrol or pterostilbene. You got to have green tea, quercetin, and iodine. These are the things that protects your body from ionizing radiation. If you are undergoing chemotherapy, you can actually improve the chemotherapy effectiveness by going into the chemo session fasting, utilizing pulse electromagnetic field therapy, because what PMF does is it opens up the cellular pores so that the chemotherapy can actually get in. Remember, you have that fibrin coat around the cells. PMF will actually help the body to open up the cells there. And then specific timing. Okay, so usually there'll be a specific time according to what chemotherapy you're using and where it's being delivered. Okay, so go and look up the different charts for active times of your organs in your body. You can find those online. And also molecular hydrogen, because molecular hydrogen will mitigate a lot of the side effects because you're curbing free radical damage. All right, here are some of the questions you guys have asked. I pulled out a few of the questions. Here's a question from Jessica. She says, where do I start? My grandfather was just diagnosed with stage 3 esophageal and stage 1 various other places. They recommend surgery to take his esophagus out. He's 80. What are the first things he should be doing? Okay, so remember I said first has to be mindset. Second part is we got to support the mitochondria. And we got to look at the epigenetic factors. And a big one, says he's a smoker and does not plan on giving that up. Well, that's going to be a hard one to overcome because the mindset there is they're already set in those ways. Whenever I see a person who does not want to give up, especially smoking, there's a lot of emotional grief that's going on. Grief, yearning, all of those emotions around the idea of yearning for something that's missing. And we got to get through that. But with that said, you can definitely try the protocols that I listed out before. Okay. Yeah, definitely acid reflux plays a huge part with esophageal cancers. But like I said, everything goes back to mitochondrial dysfunction. But if the mindset is, I really don't care about my health, then that's where everything needs to be addressed. Sarah's asking, is having a body in a state of constant stress an absolute requirement for cancer to develop? Not necessarily, but it will prolong or make it very difficult for your body to switch back because you're in that fight or flight mode. And can you speak to the stress cancer connection? Yes. Okay. So, like I said, when you're in that stress mode, what happens is that your immune system is suppressed because if you're running away from a saber-toothed tiger, your body doesn't care if you digest an apple, doesn't care if you fight off the flu, and doesn't care if you make a baby. It just cares about surviving. So, what does it do for survival? It increases blood pressure, increases blood sugar so that you can run away. You get more muscle activation and you got more energy. That's why we see a lot of hypertension, we see a lot of diabetes, and it's all because of chronic stress. And if you go back to the state of the stages of homotoxicosis, if you're in a constant state of stress, you also don't detoxify properly. So the cells are being bombarded with toxins, it doesn't eliminate the toxins effectively, and it crosses that threshold to get into the cell, which messes up with cellular metabolism. Ultimately, the cells respond and they say, I'm not happy anymore, and they become neoplastic. All right. Number 2 is, can you speak a little bit about breast cancer? Is there an increasing prevalence? If so, can you speak to the reasons for this? Because it seems too common of a disease. I posted out recently or a couple months back the correlation between root canals and breast cancers. So if you look at our diets have changed. There's a great book by Weston A. Price called Nutrition and Physical Degeneration, where he went around the world looking at indigenous populations, and after they changed their diet from their indigenous diet to a westernized diet, their oral cavities changed, so did their microbiome and all that stuff. So when people are utilizing a primarily westernized diet, specifically high in sugars, and they're underneath a lot of stress, you're going to get a lot of oral cavity issues, which then will affect your root canal issues, and the microbiome within your oral cavity goes off. And then what happens with root canals is that you get all these little pockets of inflammation and pockets of infections, which will then drain through your lymphatic system from your oral cavity down, and your lymphatics drain through your neck into the thoracic duct, which goes right under your collarbone, affecting the lymphatic tissue surrounding the breast, and it starts to damage a lot of the surrounding breast tissue. Okay, so yeah, is there an increasing prevalence? Absolutely, because of everything that I just said. Is there a genetic component? Well, like I said, it's only 5%, right? Even if you have the BRCA gene, the gene in and of itself is just the hardware. The software has to be is the thing that activates, right? The epigenome, which activates the different types of the genes, because the BRCA is only one of them. But yeah, a lot of, like I said, a lot of times people say, "Oh, cancer runs in my family." Well, no, habits run in your family. We all possess the different types of genes for cancer. So it's just looking at the lifestyle factors that instantiate those genes. That's the thing that needs to be addressed. Is there a genetic component that increases the likelihood or predisposes someone whose blood relative had breast cancer? of also developing breast cancer. So yeah, because you're a carrier, you have to be more mindful of the things that activate the gene. It doesn't necessarily mean just because you have it, you're going to develop it. Okay. So just think about this. You have a light switch in your house, something has to turn it on. If you understand what those things are and you don't utilize those things, or you use things that block the activation, you'll be okay. Okay. I think a lot of times in the world of oncology, we've gone this knee-jerk reaction to saying, well, everything's genetic when we know it's only like 5%. And we've gone through drastic measures, like I talked about earlier with Angelina Jolie. She tested positive and then she had a double mastectomy. Doesn't necessarily mean that that's going to do anything. Doesn't necessarily mean she would have gotten it in the first place. But if you look at it, the surgery in and of itself is a stressful occasion. So now you're also messing with the matrix, right? You're not the movie, the Matrix, but the extracellular matrix. You're creating a lot of inflammatory compounds. Those become activating factors for the genes. So you can see how what people think as preventative measures can also become the instantiating factors. That's what I'm saying here. As always, thank you for all the truth you put onto the road. Oh, you are welcome. Now, with all that said, I always wanted to paint a bright picture. There's a pot of gold at the end of the rainbow. These are some of the patients that I got to work with and watch them come into my office in a state of disarray and seeing them get turned back to health. And you guys can read some of these stories, and being able to witness somebody go from a state where they're not doing well to a state where they are, that's the most fulfilling part about what I get to do. Here was one of them. They got to spend more time with their mom. Here's another patient that she didn't have the best results initially, and when we started working together, we got her immune system back up, and she got more. The family got more time with her as well. Here's another one. Is one of my favorite stories. Hospice, 3 months to live, stage 4, and we ran through the protocol, and you know what? He made it. So these are all some of the cool stories. I get these text messages. Hey, oncologist says all the blood work looks normal. Tumor markers are normal too. CT scans, no fluid in the lungs, and no sign of cancer anywhere. And other other stories that people sent in to me. Now, does this happen for everybody? Not really. There, like I said, there are some parts where the body just can't keep up, and we gotta look at those things. And sometimes people, whenever they come to me, they've crossed that threshold where the body is just too far gone, where it just can't make those reverses. Now, with that said, have I seen cases where they could? Yeah, absolutely. Like I always tell patients when they walk into my office, if you're breathing, we still got a chance. If you're breathing, you still got a chance. Your body wants to survive. We just got to give it the things that allows it to. So that was a pretty comprehensive thing for this month's webinar. Hopefully you guys got a lot of stuff out of that. If you guys got questions, put it in the comments below, and then I can kind of go over that. Because like I said, in no way is this a comprehensive lecture on cancer. I just wanted to give you guys a little deeper dive than what we've been talking about in the social media posts and all that kind of stuff. And so hopefully this was helpful. Again, it's Dr. Mike saying be well and aloha.